Okay, so good afternoon, everyone. So still on our exploitation of the properties of the Christoffel symbol. Today, then, we are looking at well, we are about to make some very real and serious exploitations and use of the Christoffel symbol. We want to show that such an integral given by this, an action, could be written in this form. Of course, this is the Ricci scalar multiplied by the square root of minus g over there, to ensure covariance. So at this point, we want to, of course, this written in this form is the same thing as that. This is contracted Ricci tensor, which gives us the Ricci scalar. So we want to see how we can manipulate this expression, so that in the end, all we will have in this integral, when we substitute the whole of this expression here, will be this. So very quickly, I'll just start with seeing how we can handle, first of all, I would like to see how I can handle the first two terms there, which are, so I can just call them maybe, let's say first two terms. Let me just use F to denote the first two terms. That's the sum of the first two terms, and that is alpha, mu nu, comma, alpha minus g mu nu, gamma alpha, mu alpha, comma nu. Yes, these are the first two terms. Now, sorry, okay, I might have missed. Actually, the first two terms will comprise, together with the product of the square root of minus g. I think to make this better, I have to really, so that I wouldn't make this mistake in the end. So this will be f, like I've said, but then it will be plus the product here of g mu nu, gamma, here I have alpha mu nu, gamma of beta, alpha beta, minus g mu nu, gamma alpha, mu beta, and here gamma beta mu alpha. So the whole of these two are multiplied by minus g. So what I really want to deal with is f. If that is the case, then moving on to where this will be quite more easier for me to handle. F, I can say, is equal to g mu nu, gamma here of alpha mu nu, comma alpha, and I'm multiplying it with minus square root of minus g mu nu here, gamma of alpha, mu alpha, comma nu, multiplying this with the square root of minus g. Okay, so one thing I can see, or I can realize, is I can write this as same the whole of g mu nu, for instance, gamma alpha mu nu times the square root of minus g. This the whole thing is the same thing as minus. So this is comma alpha here minus just gamma alpha mu nu g mu nu square root of minus g comma alpha. Yeah, I believe these two terms is the same as this. You can see the derivative, partial derivative is on the Christoffel symbol alone. These two combined together, two as a factor, or these two factors combined together gives us this combination. So it's like saying differentiate the whole thing actually with respect to x alpha, but then subtract that case for which these two are differentiated. Of course, you realize that one way to write this is by saying differentiate this first, keep these two constants, then later keep the two constants, differentiate that. And so we'll just subtract off the one that wasn't present originally. So these two terms combined is the same as that. Okay, if that is clear, then secondly, I can simply take minus, let me open a bracket here, I can say that it's also the same as g mu nu, gamma alpha, mu alpha, square root of minus g. So just like the first case, gamma alpha, mu alpha. Then what I have here will be g mu nu, square root of minus g. And this is also going to be comma nu in this case. Yeah. Now we can go further to say that this is the same thing as saying, so maybe I may need, since I'm doing this way. So this may be the same thing as saying, I'll simply just combine, these two terms here. So I can say that g mu nu gamma alpha mu nu square root of minus g, comma alpha is going to be adding, because this minus will get to that. Okay. I guess I have made a mistake here too, because originally this should have been just like I had here. This should have been comma nu. Yes, exactly. It should have been comma nu, because it will be when I subtract that out, I'll be left with differentiating that alone. And that is what I had originally from this place. So okay, so if that is the case, I guess I made a mistake with that. So if that is the case, all I'll have will be minus, actually, and not plus. So that will be minus of g mu nu gamma alpha mu alpha, the square root of minus g, comma nu. And then finally I'm left with, on the other hand, minus gamma alpha mu nu, g mu nu, square root of minus g, and then comma alpha here. But then I have here a plus of gamma alpha mu alpha g mu nu, square root of minus g, comma nu. And let's say I'm able to write this, and on this point, at this point in time, I guess, yes, I can make an interchange here. Alpha is a dummy index, so is nu here. I can decide to make an interchange of alpha and nu. And if I did that, of course, the first time here, which I have not made any transformation on, remains just what it was. And so this will become an alpha minus. This will be g mu, but instead I'm going to have an alpha there representing that, and then the alpha here becomes nu. This is mu, this is nu, square root here of minus g. Instead of the comma nu there, it becomes comma alpha. That's what I get for that. So let's say that this is all plus some g. Okay, now I'm not going to use the g because it will cause me some confusion. So let me call it f sub 1, f subscript 1. In other words, where f subscript 1 is equal to minus of gamma alpha mu nu g mu nu square root of minus g, comma alpha, plus here alpha mu alpha g mu nu square root of minus g, comma nu. So that is what I'm calling f1. I think at this point it will be very good for me to sort of write this expression somewhere. Maybe I can select a place over here around the board where I can, so that I wouldn't have to. I have f here to be equal to g mu nu gamma alpha mu nu square root of minus g, comma alpha, then minus of g mu alpha gamma nu mu nu square root of minus g, comma alpha, and what I've got is plus f1. Now remember what f1 is. F1 is this combined with that. This and this, by the way, has been written in this form. After writing it in this second form, changing mu to nu on this term, I've got them combined with this form. So this is what f1 is combined. So again, I think it will be good. I say that f1 happens to be minus gamma alpha mu nu g mu nu here, square root of minus g, comma alpha, but then plus gamma alpha here, mu alpha g mu nu square root of minus g, comma nu. Okay, so having done that, I think it would be good for me at this point, just to make things elegant, to continue. I want at this point in time to manipulate these remaining last terms here. What I'm going to do is to try to evaluate these brackets. I have here with me multiplying Christoffel symbols. I'm leaving these two alone because I just have Christoffel symbols. Yes, I have a derivative for all of them. I will later on actually, I will have to combine these two terms since they are both differentiated with respect to x alpha, which was my reason for making the interchange I made for that second term. Now on this term, we can see that f1 is equal to minus some gamma alpha mu nu What we've got here is, first of all, some g mu nu, comma alpha, multiplied by the square root of minus g. And then next I'm going to have plus g mu nu, but then I will have here with me square root of minus g, comma alpha. Yes, that's what that is. And then the second term there becomes plus here, gamma, mu alpha. This will become alpha here. G mu nu. This becomes comma nu, multiplied by the square root of minus g, plus g mu nu. I have here with me square root of minus g, comma nu. And that is it. Okay. How do I simplify things here? Well, I have here a partial derivative of this with respect to x alpha. I can, in order to work with this, write them out completely in terms of just the Christoffel symbol and maybe metric tensors. What I can try to recall is that g mu nu semicolon alpha should be 0, but this is also the same as g mu nu comma alpha plus. I'm going to try to use the same contracting indices and differentiating with respect to alpha. I use a gamma here, I contract mu. This is g gamma nu, and then this will be plus again alpha. I'm using gamma as contracting index. I'm leaving mu alone, but I'm contracting nu, so nu comes over here. And this will imply, by the way, that g mu nu, okay, so I didn't write that wrong. G mu nu comma alpha should be equal to minus of that being equal to 0, alpha gamma mu, g gamma nu minus gamma nu, I believe, alpha gamma, and then this is g mu gamma. That is what that should be. And then also remembering again that for this, so let me just go ahead with the 2, or I might as well decide to contract this. I hope I'll not be running into any, no, I think, if I'm being patentic here, I will simply set them both equal, so no point. I should have faith in that. I think if I contract mu and nu, I will simply obtain what the result should be for this one. That's mu, nu, comma nu, instead of alpha. This is comma nu here. Well, but should in case we have any problems in future, we'll always come back here. Hopefully that wouldn't be too late. So what I've done is simply to change alpha everywhere in the expression to nu to obtain the corresponding expression for this, so that I wouldn't have to go through all finding covariant derivative and making that a subject of formula. Moving on, I will need to substitute that. Okay, before I do that, and things are proliferating already, I have here with me, so I think I'll have square root of minus g, this is comma alpha, which means I'm differentiating this with respect to x alpha. This is the same thing as, I want to believe, the g, the x alpha, the square root of minus g, the g. This then should be equal to, if I were to perform for this, I'm going to get a minus 1 from differentiating this, times some half, times minus g here is power minus half, and then that will be, so this will be the g, the x alpha. So I guess here this will be minus of 1 all over. Okay, so I have here with me twice. Again, since I'm doing this d the g, I'm guessing there's nowhere here that I have a g, so this is simply going to be minus square root of minus g. That's what I should have below. I have the minus sign represented, and then finally the g, the x alpha. So in essence, so I'm going to try to be very quick with this, but then we already have a result here. So quite straightforward as for this one. So in this case, we can say that the g, the x alpha is the same thing. This expression we have obtained in the previous presentation, can't remember exactly which one, but I'm pretty certain we did that already. So I'll simply just put that. So this is what we have for that. In other words, I can substitute again for what I've been doing all this while, minus g raised to the power comma alpha this is comma alpha, I'm going to get minus 1 all over 2 the square root of minus g. And then in place of that, I'll put here dot 2 times g gamma mu alpha mu. Of course, these two go. What I've got here is sort of minus g all over the square root of minus g gamma mu alpha mu. I don't see. Okay, we can simplify this further by kind of rationalizing this, multiplying up and down by the square root of minus g. Of course, eventually we're going to get something like the square root of minus g multiplying mu here alpha mu. So in other words, this is what that gives us. Or maybe, well, since I'm going to be raising this anyway, so let me just put that somewhere here. We have been able to establish that the square root of minus g comma alpha will give us the square root of minus g multiplied here by gamma mu alpha mu. That's what we just saw now. Hopefully we have not missed anything. And the next is, if that is the case for that, if that is true for that, then it also means that the square root of minus g here, comma nu, this should be the same thing as that. Gamma, of course, nu must be represented here. For some reason, let me just maintain the same dummy indices in both cases. I could choose two different dummy indices if I want. So we have obtained expressions here that are quite very interesting or important to us here. So, well, let me just erase this, since up until this point, we haven't made use of these two expressions yet. Now, at this point in time, I'm going to be substituting. So F1 becomes minus gamma alpha mu nu. Then in the bracket, I think I may want to use a block bracket here, so that in that bracket, I open up this one. In place of that, I have minus gamma mu alpha gamma g gamma nu minus that nu alpha gamma g mu gamma. I close the bracket, multiply that with minus g. Then I have here with me plus, I have some g mu nu. But then, of course, again, I already know that this is that times the square root of minus g. I have here with me mu alpha mu. And that is what I get for that first term. Yes. And so again with the block bracket. Next, I'm going to have plus here gamma alpha mu alpha. And what have I got? Okay, I said I was going to use a block bracket. So I'm going to open up a block bracket like this, or a square bracket. Now the next thing I'm going to have is this. So in place of that, I put this. So I open a bracket minus gamma mu nu gamma g gamma nu minus that nu gamma g mu gamma, that, and then multiplied by the square root of minus g. And so the next thing we're going to be getting is plus, again just like we had in the other case, g mu nu. Here I'm going to have the square root of minus g multiplying, but then mu nu mu, and that will be it. Okay, so what do we get next out of this? I will simply just open up the bracket and see what it looks like. So we are free to wipe this out. Opening it all up, and now again F1 is still what we are working on. So this times that, and of course again we should remember accompanying this. So the first term there is going to be gamma here, alpha, mu nu, and then gamma here, mu alpha, gamma, g, gamma nu, and then here the square root of minus g. And here I'm going to have plus gamma alpha mu nu, and then I have also gamma nu alpha gamma. I have g mu gamma times the square root of minus g. Multiplying that also is going to be some plus g mu nu square root of minus g, but then this okay, so I'm not going to have a plus, sorry, it will be a minus because this minus sign will have to accompany this. So this will be a minus that, but then it will be gamma alpha mu nu, and then here gamma mu alpha mu. That is that for the first square bracket. And the second one there will be minus, yes, minus, that's what it should be. Alpha, mu, alpha, and then I have again gamma, mu, nu, gamma, g, gamma, nu, all multiplied by the square root of minus g. And that's what we get for that. Next, we are going to have a minus some gamma, alpha, mu, alpha, and then I have here with me gamma, nu, and then here nu, gamma, g, mu, gamma, square root of minus g. Hopefully we haven't mixed up any of this, what is it called, indices. Otherwise we'll have some very serious problems. And then next we are going to have plus g mu nu square root of minus g, and then I'm going to have gamma alpha mu alpha, but then again gamma mu nu mu. And that is it, all the terms in F1. Okay, now we can try to see if we can be fortunate to cancel some or all of these, and everything will be easy. Looking at this, okay, so I have g gamma nu, g mu nu, g mu nu, g gamma nu, g mu gamma, and all that. So what I would like to do is, let me see if I can change, make transformations that will give me g mu nu, g mu nus all throughout. If I'm able to do that, then maybe I can be fortunate enough to make some cancellations. But then maybe without that, we can see, looking at this last two terms, last two terms, if I change nu, yeah, nu is a dummy index. If I change that to gamma, I think these two terms will cancel. Yeah, if this were gamma and this were gamma, this is mu alpha alpha, mu alpha alpha, and this is nu mu nu. Yeah, so if this were gamma indeed, then it would be the same. And nu doesn't matter, even though it's nu. I could as well change this also to nu. I like to believe that this last two terms cancel. It's a matter of just looking at it together again. Let's go through this once again. And besides, I think we already made a mistake somewhat. It's a pity because I have four terms here, dummy indices. And this is a very serious issue. Okay, let me just hope that this all problem, and I think this started all from here. What I should have done actually was to have actually changed this into completely foreign indices that were not already present in any tensor term here, and that way we can conveniently make sure that all these are changed. Well, fortunately for us here, the interchange we need to, I like to believe this to cancel. The interchange we need to make isn't between mu and nu or mu and gamma. It's just nu, and nu occurred just twice. That was a very dangerous move over there. But hopefully this wouldn't affect us. Again, but that was a very serious mistake. I need to apologize on that one, but anyway, let's just move on. Moving on, looking at this, these two here. Okay, we can't hope to have any cancellations. If I change, so let's just make the changes. So I'm going to make the change here between gamma and mu. That is interchanging gamma and mu. Wherever I see gamma, I put mu. Wherever I see mu, I put gamma. That's the reason or meaning of that. And then this will become gamma and nu. Wherever I see gamma, I put nu. Wherever I see nu, I put gamma. And these are dummy indices, and we don't have them, fortunately for us, more than twice they are occurring. And here also I have, okay, this is just okay in terms of what I want. And this one here, I can make an interchange between gamma and mu. Again, we're very fortunate that mu occurred just twice and nu occurred twice. So in that case, what I'm going to do is, if I did that, I'll have this first of all to be that. Gamma, I said gamma and mu, right? So I wasn't supposed to write mu here again. This is supposed to be, again, gamma. And then this will be gamma. This will be alpha, but then this will be mu. G, this will be mu, nu, square root of minus g. And then the next one plus here, alpha, mu, nu. And then this here will be, okay, I'm making the change again between gamma and nu, so I shouldn't have a nu here. This should be gamma. And then this should be gamma. This will be alpha, nu, g, mu, but then nu, square root of minus g. Do they look alike now? I have gamma nu here, and I have gamma mu, not gamma nu, and I have mu. Okay, so one thing I can do is subsequently I can decide to make an interchange between nu and mu. Okay, before I do that, let me just go ahead with making the other interchange that was listed for the other remaining terms. I think since we have taken care of this up, well, let me just not go ahead of myself. And then I can say this is the same thing as minus g mu nu. We have no transformation on this term. Minus g gamma alpha mu nu, gamma mu alpha mu. And then I have here minus gamma alpha, gamma alpha, gamma, gamma here, nu mu, g mu nu, square root of minus g. So this is what we have finally. So like I was saying, if I make an interchange on the very first term here between mu and nu, so hopefully what we did before didn't make any effect. If I made an interchange here between mu and nu, I think what will happen is this. Let me just go straight ahead and have that. Let's see how all that looks like in writing. This is mu, this is what it becomes. This is gamma, this is alpha, this becomes nu. Of course, our metric tensor might as well be written as that. Nothing changes on that term, or on that factor. This is now here alpha mu gamma, gamma alpha nu, g mu nu, square root of minus g. Okay, did we get what we are hoping? Yes, we indeed got what we are hoping for. These two terms are exactly the same. And what about these last two terms? Have we gotten anything really? G mu nu, square root of that, alpha. Okay, so we might want to make some changes here too. We have a gamma here, which, by the way, is a dummy index. And if I were to change this gamma here to mu, will it be the same? Okay, then I'm going to have some alpha, mu, alpha. So I think simply changing gamma, which is a dummy index, to, okay, no, not changing. I can make an interchange. Our metric tensor remains the same. And yeah, I believe so. Our metric tensor remains the same, except of course, the problem we might be having is that this will not look the same like what I was expecting or hoping for. And this is one of the few times again that one of the problems we have. You can notice we have mu. In fact, okay, so this is quite terrible, but well, we can work on this one. We can work on this one. And working on this one will mean, let me interchange mu and nu. If I interchange mu and nu, I'm going to have this to me. If I interchange mu and nu, nothing will happen actually, because these two terms, mu and nu, okay, nothing will happen. These two remain the same. But if I interchange mu and alpha on this term, let's do that. Mu and alpha. Let's interchange between the two. So what I'm going to get is, here will still be minus g mu nu, square root of minus g, gamma alpha mu nu, gamma here mu alpha mu, minus gamma alpha gamma. Okay, no, so it wouldn't be alpha again. It will be mu, like we wanted to change that. That will become mu. This becomes still gamma gamma. This becomes nu, but then it becomes alpha here. This gives me g mu nu, the square root of minus g. Okay, looking at these two, now what have we got, or what have we done really? Okay, again, I think it's at this point that I will have to make the interchange between mu and nu. Yes, on this one, I think if I made that interchange, what was I working on? This is the first two gotten from that, right? I hope the interchange I've made is on this term. Yes, that is it. Mu, and this is gamma, and the mu here was supposed to be alpha, and then the mu here also is supposed to be alpha. I'm guessing that was because of my problem. That is what it was supposed to be. Okay, so at this point, I guess finally what I will have to do is, so what is obviously causing this problem, and I hope we really get out of this quagmire, is the fact that I have maintained this, if we looked at this, and which is why in tensor analysis, and I always frown at it in particular because you are certain to run into problems like this or even worse, even get things wrong. It is not allowed mathematically for you to have more than two terms, more than two repeated indices on any term. And you find it even in some books, I have to tell you, that do these things, whereby you have more than two terms or two indices, an index repeated more than twice on a single term, and that is all wrong. Because then you get confused. I can tell where these two are coming from because I am solving the problem. I followed it initially right from the beginning, so I can decide right now to change all those indices backwards. But supposing you didn't solve the problem right from the beginning, how can you tell one from the other? You see, someone else who wasn't on solving this problem will not be able to learn that. So it's quite unfortunate we ran into this problem, but maybe it was a good thing after all. It will show us just how to get out of some of these problems. So one thing I can try to do, for instance, on this time that I know that these dummy indices are locked together. That is one thing that I know. Yes, so I know that this dummy index has no relationship with these two. If I want to make them relate, fine, but I know because I started and this was where it came from. So one thing I can try to do, because I know that, I can call this both delta. But again, it's going to, how am I going to put it? I think in the end I'm going to get these two to be the same after all, because you can see that if I had these two to be delta, I can interchange between delta here, or since after all I have gammas here and I don't have any gamma on this term, so in order to just move straight forward with something that will help me, I can change it to that. Then on this term I made the interchange between gamma and mu. The first two terms, by the way, we can see and we already agree are the same. So what I have is two of this. Alpha nu, g mu nu, square root of minus g. Now if I made this interchange like I was saying, I'm going to have here minus g. What have I got here? What I've got here is this becomes a gamma. Yeah, that becomes a gamma. This is a nu, square root of minus g, and then here this is going to give me an alpha, and then instead of this mu here I'm going to get a gamma, and this will give me a nu, and instead of this gamma here I'm going to get a mu, an alpha, and a mu, and then finally that will be minus mu, gamma mu, gamma alpha, nu alpha, g alpha nu, square root of minus g. Well, let's take a look again. We have two dummy indices here, just like mu mu here, gamma. On this term, I have mu mu, but alpha, not gamma. Here I have the gamma, you can see repeated across like that. Here I have my alpha repeated across like that, just twice. Now, but then one thing is common here. So, but just to make you see things here, I have another dummy index on this term with gamma here and then gamma here. So I have gamma nu, but here I have alpha nu. But the nu here that I had with me is with gamma. So finally you can see either on this term or on this term, whichever one, if I make the interchange here, for instance, between gamma and alpha, you can see that this will be the same as, so let me wipe all this. This has been a long time coming. So I would strongly suggest and advise, because actually this is the general rule, one of the most traditional rules in tensor analysis. It wouldn't make sense for you to have more than an index repeated more than twice on any term. Repeated twice means they are contracted. I mean, the third time doesn't make any sense. And I'm having these problems because of that mistake. I'm even able to wriggle from it because I'm aware of the problems. So maybe some of the authors who make this mistake, or should I say, who are cavalier about this. So on this term, I'm interchanging gamma and alpha. So this becomes alpha nu, square root of minus g, gamma, but then this is gamma, and then this is alpha, but nu, gamma here, mu, but instead of alpha, gamma, mu. And then I think we're home. I think some people who are experts with the use of tensor analysis can get out of this problem quite easily. And sometimes when they're writing, they kind of just, their style reflects in their writing, and of course that would be expected, but it's wrong for someone to make that mistake. Finally, I think they're all the same. This and this is the same. This is in fact exactly the same as that, and this also is exactly the same as that. So I know where I'm going, and I know where I'm coming from. I know what caused my problem, and that is why I'm able to wriggle out of it. But that is not even an excuse for me to have made a mistake in the first place. I shouldn't have. And if anyone is marking this as an exam or something, there should be some subtraction. Yes, there should be some penalty for being that cavalier, because that would be doing the wrong thing. Okay, so I have this to be written in this form. I think I'm just quite okay, but this is F1. This is what we've got to be F1. And what is F1? F1 was originally equal to this, remember. And why did I do all this? We had derivatives here, which if you remember, were expanded all through, such that we differentiated this, kept this a constant, kept that a constant, differentiated this. You remember we used the covariant derivative of a metric to find what we'll have to substitute for the partial derivative of this. And of course, the derivative of both this, you can see we were able to show gives us that. So with all that, we're able to write this F1 into this. And now with this expression, we're going to substitute back into what F was originally. Excuse me. Now at this time, I'm going to say that F will then be equal to, so I'm going to combine those two terms there, G mu nu, and this is gamma, alpha mu nu, and then the square root of minus G mu alpha and then square root of minus G. Okay, so I think at this point I should make some recommendations for some very good books on tensor analysis. So plus F1. So I'll be doing this while I'm talking. This is F1 equal to this, and the F1 we have written to be this. So instead of that, for F1 I'm putting this. So plus here, okay, maybe I can just say plus twice, right? I think twice of that is what I've got here. Yes. So I'm going to put twice. No need putting it in a bracket. So let me write them all as separate. So as I was saying, two good books actually, yes, for any beginner in tensor analysis. Shum series or Shum outline tensor analysis is a good one. And then you have Relativity Demystified by David McMahon, and some of you know him. It's a very popular text. I have to really say that they did a good job in trying to simplify a lot of things. And that would be very helpful and encouraging to anybody having problems with either tensor analysis in general or general theory of relativity. Okay, that is what I have for F. And where did F all start from? F started from this place.